Hello everyone, in this video we will solve certain questions from A levels past papers of permutations and combinations. Throughout the course of video, I will assume that you have basic knowledge about permutation and combination. For basic understanding, you may watch my other videos in which I will explain the basic concepts about these two things. In this video, I will specifically solve certain practice questions which are from A level past papers and can be equally related to CA QT AFC examinations. Let us move on to the first question and solve the questions. Let us start solving the questions. The first question says a word is made by writing the 7 letters used to spell example in some order. Find how many different words are possible in each of the following cases. Now we have a word which is example, and we have to form other 7 letter words. We have to write down the possibilities of how many 7 letter words can we form from the letters of the word example. Number 1. The first and the last letters are each E. The question states that the first and the last letters should be E. They cannot be other than that. Now to solve this type of question, we can draw a rough diagram, boxes, and we know that the first letter is supposed to be E and the last letter is also supposed to be E. There were 7 letters in total. Now if the first letter is E and the last letter is E, we are left with 5 letters which can arrange themselves between this in 5 factorial ways, and which is equivalent to 120. This was part number 1. To minimize the size of video, I will be solving these questions in a hurry. You can always pause the video, go through the questions again and again and solve your queries. Even if then you don't understand anything, you can approach me through Facebook, Taha Popatia, or you can email me at taha_popatia@hotmail.com. Let's move on to the next part. The next part says that the two letters E are next to each other. Now if the two letters are next to each other, and we have 7 letters in total. If you have 7 letters in together, which will make it 1, 2, 3, 4, 5, 6 and 7, and both E's are together, these both E's make a block in itself. Now this is our first block, this is second, third, fourth, fifth and sixth. All of them can arrange themselves in 6 factorial ways, and by 6 factorial it will be equivalent to 720. Moving on to third part. The third part says that two letters E are not next to each other. Now what we can do here is that if we calculate the total possible arrangements, by total possible arrangements I mean that some of these arrangements will have both E's together and some of them will not have E's together, and I subtract the ways in which E's are actually together. This includes together and not together, and if I subtract from it together, I will be left with not together, the arrangements in which E is not together. Well, actually this portion represents all possibilities of arranging 7 letters words, which will be 7 factorial divided by 2 factorial. 2 factorial is because there are 2 E's, and for repetition and permutation we avoid or to negate those repetitions or repeated words, we divided with the number of repetitions permutation less 720 we calculated in first part. So this will be left with 1800. So there are 1800 possible ways in which the both E letters will not be together, which is absolutely opposite of what we did in part number 2. Moving on to question number 2. Question number 2 says 3 married couples, Mr. and Mrs. Lee, Mr. and Mrs. Martin and Mr. and Mrs. Shah, stand in the line for a photograph to be taken. Now there are 6 people, 3 men and 3 women. Find a number of different ways in which these 6 people can be arranged. Number 1, if there are no restrictions on the order in which they stand. If there are no restrictions, the 6 people can arrange themselves in 6 factorial ways, which will be equivalent to 720. part number 2. If each man stands next to his wife. Now if each man stands next to his wife, by that we mean that since there are 6 people or 3 couples, we can have a man, woman or first couple, then we can have a man and woman second couple, then we can have men and women, which will be our third couple. Now the question states that the couples should be together. Let us read it again. If each man stands next to his wife. For a man to stand next to his wife means that the couple has to be together. Now let's say this is couple A, this is couple B, and this is couple C. In itself, A, B and C, or the 3 couples, can arrange themselves in 3 factorial ways. Within a couple, a man can stand at left and his wife on right, or vice versa. So within each couple there are 2 factorial or 2 arrangements, and since we have 3 different couples, they can arrange themselves on left and right, which will be again 2 factorial into 2 factorial, which makes it 48. Moving on to next question, which is question number 3. Question number 3 states, if no man stands next to another man. This means that since we have 3 men and 3 women in question, the question wants us to say that the no 2 men stand next to each other. Well, since we have 6 people in total and 3 are men and 3 are women, we can actually plot certain possibilities. 1, 2, 3, 4, 5, 6. So I have drawn this in extra box. There should be 1, 2, 3, 4, 5 and 6. Fine. Men, women, men, women, men, women. This is possibility number 1. Second, woman, men, woman, men, woman, men. This is possibility 2. Third, men, woman, woman, men, woman and men. 3. And the fourth one should be men, woman, men, woman, woman and men. 4. So we can say that there are 4 possibilities in which 2 men will never be with each other. However, in each of these possibilities, now let me illustrate this by our first possibility. The first possibility was men, woman, men, woman, men, woman, and 3 men and 3 women. The first one was okay. That's fine. Now this is the first man, this is the second man, and this is the third man. And since we have 3 men, anyone can occupy this place. After one of them has occupied this place, any 2 can occupy this place. After one of them has also occupied this place, the last one will occupy this place. So the men can arrange themselves in 3 factorial ways. Likewise, there are 3 women. Any of the 3 can take the first place. After that, the remaining 2 have an option to sit on the second place, and the remaining will have an option to sit on the third. So the women can themselves arrange themselves in 3 factorial ways, men can arrange themselves in 3 factorial ways, and then there are 4 possible arrangements as we discussed above. In totality, 3 factorial into 3 factorial into 4 will be 144. Moving on to the next question. The next question says, in a class of 20 pupils, 7 are left-handed and 13 are right-handed. 5 people are selected and enter from the class. The order in which they are chosen is not important. Now here the order is not important, and if order is not important, it is a combination. Find a number of possible selections in which 2 of the 5 are left-handed and 3 are right-handed. Now if 5 are left-handed and 3 are right-handed, if you have to select the number of possible selections in which 2 of the 5 are left-handed and 3 are right-handed, we have altogether 7 left-handed people. Question number 3. And we have to select any 2. Multiplied by, we have 13 right-handed people, and from 13 of them we have to select 3. So it should be 7C2 into 13C3, which is 6006. Number 2. The probability. Now, to calculate a probability, we know probability is favorable outcome divided by total possible outcomes. The probability should be 6006 divided by total possible outcomes. The question is, find the probability that a sample of 5. Sample of 5 means if you have to select 5 people from 20, will include exactly 2 who are left-handed. Now if you have to select sample of 5 from 20 people, the total possibilities will be 20C5. The sample of 5 will include exactly 2 who are left-handed. If 2 are left-handed, other 3 would be right-handed, which means this. And this will be equal to 0.387 or 38.7%. Moving on to next part, or question number 4. The question number 4 is, a competitor involves listing in order the best 6 features of a certain car. Now note that the word order is in italic. It is important here to analyze what does this mean. If I say I have 3 choices, A, B and C, and my order is important, I will apply permutations. For example, if I have to select any 2, A and B, it is a combination. But if I have to select them in an order, like if I have to award them for something, so if I select A first and B at second, it is entirely different from selecting B at first and A at second. Over here we apply the concepts of permutation. So in our specific question, it says a competition involves listing in order the best 6 features of a certain car. If I am ordering or listing the features of a car, we will apply the concepts of permutation. Since for example, if someone rates feature A at number 1 and the feature number B at number 2, it is entirely different from ranking feature number B at first position and feature A at second position. These two things are entirely different. So in this particular question, we must apply permutation. It says a competition involves listing in order the best 6 features of a certain car. There are 10 features to choose from. You have to choose from 10 features. You have to choose only 6 features, and the order is important here because changing the order will rank them in a different way. Peter makes a list of 6 features. How many different lists could Peter make? He is not making a list of features, he is actually making a list of features along with ranking them in order or giving them a rank. So it should be 10P6, which will be 151200. Moving on to next part, part B. Part B says the word mobile consists of 3 consonants MBL and the 3 vowels OIE. How many different arrangements of all the letters of the word mobile are possible if the vowels must be next to each other? Vowels are supposed to be next to each other, and since we have 3 vowels, the 3 vowels will form a block in itself, and we have 3 other letters. So arranging them will mean that this block is 1, 2nd, 3rd and 4th. These letters are independent, whereas this is a block. We have 4 factorial arrangements for them. Furthermore, within this block, we have 3 letters which can arrange them in 3 factorial ways. And in totality, it will be 144. So this is the end of the first video. I will keep uploading videos about A-level lectures, ACC and CA lectures as soon as I get time. You can always inbox me at my Facebook, or you can write to me at Taha_Popatia at hotmail.com. All the best all the students. I will keep on uploading more videos in future. Thank you.